Hello, smart mathematicians. Let's do question 9.1. In the diagram, O is the center of a circle. OD bisects the chord AB, meaning that it cuts AB into two equal parts, so that AD is equal to DB. Prove the theorem that states that the line from the center of a circle that bisects a chord is perpendicular to the chord. Basically, we are required to prove that OD is perpendicular to AB. Okay, right. When you're proving a theorem, there are two main things that you have to remember. One, you have to remember the construction or the constructions that you have to do, and you have to remember the theorem that you have to use to prove your theorem that you are proving. Right, so let's start with the constructions. We're going to construct OA and OB. Right, the radii. So we have radius OA, and then we have radius OB. Right, that's the construction we have to do. And then what are we going to use to prove that OD is perpendicular to AB? You have to remember that here we use congruency. So if you check, we have created two triangles. We have created triangle ADO, and we've created triangle BDO. We have to use congruency here to prove that these two triangles are congruent. And then from congruency, we can find the equal angles or the equal sides. But here we want to prove that OD is perpendicular to AB. So you have to prove that this angle D1, let's call it D1, this angle D1 is 90 degrees, and angle D2 is also 90 degrees. We have to use congruence to prove that, and later on we're going to use adjacent angles on a straight line, because ADB is a straight line. Right, let's prove congruency. So in triangle ADO and triangle BDO, so we have these two triangles. So what can we do? There are two ways of doing this. We can use side, and also side, angle, side. Okay, I'll show you side first, and then after that I'll show you side, angle, side. Okay, let's start with side. So we have these two triangles, ADO and triangle BDO. Side OA is equal to side OB. Right, and then what's the reason? We're saying radii. OA and AB are radii. And then we have OD. OD is equal to OD. It's a common side. If you check, we have two colors here. We have both blue and green. So OD is equal to OD. And then the reason, you can say common side. And then the last one, we have AD is equal to DB. And then the reason you write, you say we're given that AD is equal to DB, because this line OD is from the center to the midpoint of AB, to the midpoint of the chord. So AD is equal to DB. So this is given. Right, we've managed to prove that triangle ADO is congruent to triangle BDO. And then the reason we write, we say side. So that's why these two triangles are congruent. Let me show you if you wanted to use side, angle, side. We could have used side, angle, side here. So we can say AD is equal to BD, and then we can say we're given that, and then we can say angle A is equal to angle B, because OA and OB are equal. These are radii. OA and OB are equal. So these are angles opposite equal sides. Okay, and then we have AO is equal to BO since these are radii. So we wanted to prove that triangle ADO is congruent to triangle BDO, and then reason is side angle side. That's another way of doing it. Okay, right, let's continue from here. So we've managed to prove that the two triangles are congruent. What does that mean? From triangle ADO, this means that is angle D1. And then from triangle BDO, that means this is angle D2. Remember, the vertices correspond. It means angle A is equal to angle B. Angle D, which is D1, is equal to angle D2. And angle O, which could be, let's call it angle O1, is equal to angle O2. That's what it means from congruency. So from congruency, we can conclude and say, therefore, angle D1 is equal to angle D2, because triangle ADO is congruent to triangle BDO. Or you can write the word congruency, is still okay. But if you check, these two angles, D1 and D2, are angles on a straight line, because ADB is a straight line. So we can say angle D1 plus angle D2 is equal to 180 degrees, since these are adjacent angles on a straight line. We have said D1 is equal to D2, so you can replace even D2 with D1 here because they're equal. So it becomes what? 2 times D1 is equal to 180 degrees, and then D1 is equal to 90 degrees. And then D1 is equal to D2, and then therefore D2 is also equal to 90 degrees. Now we've managed to prove that OD is perpendicular to AB, because this angle is 90 degrees and this angle is 90 degrees.